In this video, we're going to explore a very common novice programming mistake in Java. In fact, it's a common novice programming mistake in many programming languages, and that is confusing a single equals symbol with a double equals symbol. So this is an example of where this mistake typically occurs. We've got somebody wanting to compare the value of the score variable against 100, and it's quite natural to write if score equals 100. So that's our inclination as to how we might read that particular expression in Java. Here's the code in context of a complete method. However, if we ask the compiler to compile the code, then we can see that it indicates that there's an error. There's something wrong with that comparison. This is what's called a syntax error. So the compiler is actually indicating that we can't use that single equals symbol there. And here the editor is suggesting that probably we meant a double equals symbol rather than a single equals symbol. And we can ask the editor to fix that for us. And now the code compiles without any problems. So what we're seeing is that instead of using a single equals symbol here, we need to use a double equals symbol in Java in order to indicate a comparison between this variable and this value. Why is it actually a problem? Why is it such a common problem amongst novice programmers in Java? And the reason is that we're used to thinking of that single equals symbol as literally meaning equals, and that comes from our math background. So in math, we can say x equals y and y equals x, and those two mean the same thing. It doesn't matter which way round we're comparing those two values. However, since the 1950s, many programming languages have changed the meaning of what a single equals symbols mean to mean assignment, which is something quite different from a test for equality. And in the context of programming languages and using that as an assignment symbol, it's no longer true that x equals y and y equals x. Those two ways of expressing assignment do not mean the same thing. And it can be quite difficult for novices to reprogram their long-term experience of thinking of that single symbol as meaning equals. And so it becomes quite natural to use it in an if test in order to compare two values, and it doesn't mean the same thing. Now, a pioneering language designer called Niklaus Wirt recognized the problem this causes for novices, and in fact programmers in general. And in some of the programming languages that he was involved in, he preferred a different symbol for the assignment symbol and preferred to use the single equals symbol as a test for equality. So he used a combination of a colon followed by the equals symbol to mean assignment in order to avoid this confusion. This particular example was relatively easy to correct because the compiler indicated that we have a syntax error here and offered the replacement, the correction. There are some situations in which it's not quite as easy to spot that there's a problem. So let's look at another example. This is a more sophisticated example where we're modeling lab classes and students who belong to lab classes. So the lab class has an array list of students, and it's possible for lab classes to have instructors, to be in a particular room, a time of day, and a capacity. And within the class, we have methods for things like enrolling students, printing a list of students, and so on. Now, I've set this one up so that we have a number of students enrolled and we can print the list of students, and we currently have 3 students enrolled in this particular class. Now, our task is to find whether a particular student exists within the class. So I'm going to find student, and I want to look for Snow White to find out whether Snow White is in the class, in the lab class. And indeed, Snow White is in the lab class as a student with an ID and some number of credits. Let's look at the code to find out whether a particular student is in the class. The method takes the name of the student we're interested in finding. We have a Boolean variable that's set to false and will be set to true if we find the student, and then we iterate over the list searching for the student. So each time around the loop we retrieve a student, make a comparison against their name. If we find them, we print them, and we set the Boolean variable to be true. Now in fact we could stop the loop as soon as we find whether the student's in the list or not. We've left that out just to keep this a little bit more simple. But down the bottom we have a test of the found variable to see whether we found the student or not. And notice that we've made exactly the same error as we had in the previous example. But this time we can comfortably compile the code without having any problems at all. So why is the compiler not giving us an error in this case, whereas it was before? So we'll come back to that in a moment. But let's look to see what the effect of that is. Let's recreate our list. Here are a list of students. We know that Snow White is in the list. Let's look for somebody who's not in the list. Let's look for Spider-Man, who we know is not a student in the class. Click on OK, and nothing is printed. So for some reason, this error message, which should have said Spider-Man is not in the class, has not been printed. Why is that? And the reason is that we now know that this symbol means assignment. So what's happening is that the value false is being assigned to the variable found, and then that false value is being used to control the expression. So this statement can never be printed because we will always be assigning false. This expression will always be false, and therefore we can never print this out. So the remedy is the same, and that's to replace the single equals assignment symbol to be the double equals test for equality. And now let's try again. Reproduce the data that we had. Now let's find student Spider-Man, and we get Spider-Man is not in the class. Let's just double check to make sure that we've got things the right way around for a student who is in the class. Let's look for Snow White, and there we get Snow White's details. So we had a problem there in that the compiler does not give an error in this case, where we think we're testing to see whether found has been false, but we're not. We're actually making an assignment of found to be false. And as before, we need to use the double equals test for equality there. So that's a little bit of a gotcha. Now, there is a way to avoid this problem overall, and that is whenever we have a Boolean variable or a Boolean expression in general, we never need to compare it against one of the Boolean literals true or false. So instead of saying is found equals to false, what we can actually do is say if the found variable is not true, in other words it's false, then we want to print this error message. So we'll see if we compile, recreate the list, look for Spider-Man. Spider-Man's not in the class. Look for Snow White. We find Snow White, everything's okay. And similarly, we can go back to this loops condition now and make use of the fact that we can finish if the found variable becomes true. So while there's at least one more student to consider and we haven't found the student we're looking for, we want to continue iterating around the loop until we get to this final test down here. So the compiler will help us when we're not using one of the Boolean literal values, but it won't help us when we are. That single equals symbol will be interpreted as an assignment, and then we'll potentially get a false positive or a false negative. So some concluding advice is that Let's try and avoid referring to that symbol as equals and instead call it something like assigns or the assignment symbol. Let's only refer to that double symbol as equals or is equal to. And if we get into the habit of using those bits of terminology, we're slightly less likely to make that error in the early stages of learning to program. We should also avoid comparing Boolean expressions with the Boolean literals true and false. We should just use the value of that Boolean expression alone, possibly negating with the Boolean negation operator, depending upon the context.